Are you having trouble understanding Newton's 3 laws of motion? Well, look no further, because in this video we're going to be covering those 3 laws with the help of Link from Legend of Zelda. So, let's get right into it. Born on January 4th, 1643 in Woolsthorpe, England, Newton made groundbreaking contributions to physics, mathematics, astronomy, and beyond. One of the most famous anecdotes about Newton involves an apple falling from a tree, inspiring his thoughts on gravity. Newton's curiosity and intellect led him to formulate the laws of motion and universal gravitation. Let's break each of these laws down. Newton's first law, aka the law of inertia, says this: an object at rest remains at rest, and an object in motion remains in motion at constant speed and in a straight line unless acted on by an unbalanced force. Alright, let's just break down what Newton's saying here because it's a little bit difficult to understand. Let's reread the first part. An object at rest remains at rest, and an object in motion remains in motion. This first part basically means that if something is not moving, it'll continue to stay still, and if something is moving, it'll keep moving. Let's use Link to help understand this. Here's Link, and as you can see, he's not moving at all. He's staying still. If something's not moving, it'll continue to stay still. And vice versa, if Link was moving, he would continue to move. This next part reads, at a constant speed and in a straight line. And this basically means that the moving object will continue to move at the same speed as it always was moving, and it'll keep moving in that same direction. Let's read the last part of Newton's law one more time. Unless acted on by an unbalanced force. An unbalanced force is a net force, which means it is the combination of all the forces acting on an object. When these combined forces are not balanced, basically they don't cancel each other out, the object will change its state of motion. Remember, this is because the object is experiencing an unbalanced force. This could mean the object starts moving, stops moving, speeds up, slows down, or changes direction. When we read the whole statement together, it makes sense. An object will remain in motion or at rest, and at constant speed, and in a straight line or in the direction that it's moving, unless it's acted upon by an unbalanced force or a net force, which in this case would change the object's speed, would change the object's direction, would make it either stop moving or start moving. Let's take a look at Link to better understand this. As you can see, we got our boy Link here, and he's still standing still. He's an object at rest. But what happens, let's say, if a force from a boulder goes and pushes Link, acting as an unbalanced force? Well, as you can see, Link starts to move, he changes his speed, he changes direction of his movement. Therefore, Newton's first law holds true. Newton's second law, aka the law of force, says this: the acceleration of an object depends on the mass of the object and the amount of force applied. Basically, it's the equation F equals ma, where F is equal to force, m is equal to mass, and a is equal to acceleration. The first thing that we need to understand is that this equation can be manipulated in 3 different ways. First, the F equals ma equation can be turned into an F net equation. Remember that a net equation is the combination of forces. Therefore, if you have a situation where there is more than one force acting on a body, you take the net force on that body and make that equal to m times a. Additionally, you have xy independence, where the net force from a certain direction only impacts that direction. The force from the y direction does not impact the x direction, and vice versa. In the example shown, we have 2 forces in the same direction, FF and FP. Let's say in the first equation, FF is stronger than FP. Therefore, FF is the net force, it equals MA. Let's use an example to help us understand the concept a little better. Right now we see Link, he's trying to drive his sled, but he can't overcome the friction force pushing against his pushing force. This is like your net equation from before. The net force in this case is FF, but if Link adds a fan, it adds to his pushing force, and now the pushing force is the net force, making it equal to MA. Another thing we can do when manipulating the F equals ma equation is showing what happens when one value of the equation is increased. First, we see Link pushing a log. He's pushing the log with constant force, and the mass and the acceleration of the log reflect that. But let's see what happens when we increase the mass but keep the force input the same. So we alter-hand a new log to Link's pushing device, and would you look at that, Link is pushing the log very, very slowly. What happened was that the mass went up, but the force input stayed the same. This caused the acceleration of the log to go down. And finally, what happens when we increase the force but keep the mass the same? Well, the exact opposite happens from before. As you can see, we got our boy Link, and he's trying to push his boat. He pushes with a leaf, and the boat doesn't go far. Then he decides to use more force and push twice with this leaf. The boat goes much farther. What happened was the acceleration of the boat increased because the force was increased. And since the mass can't change, the only thing that could change was the acceleration, and it went up. Anyway, this sort of manipulation using equations is super important in physics. It can help us understand trends without using numbers at all. Very awesome. Now let's move on to Newton's third law. Basically, the law of action and reaction. Basically, the law states, and you guys have probably all heard of this before, for every action there's an equal and opposite reaction. Again, what does this mean? Well, big ol' Newton is trying to say that when object A pushes on object B pushes back on object A with the same magnitude, meaning the same amount of force in the opposite direction. Let's use our buddy Link to help us get a better understanding. Right here, Link is riding a boat. The way the boat works is by using a fan. In this case, the fan pushes the air in one direction, and then the air pushes the fan back with the same amount of force in the opposite direction. And since the fan is attached to the boat, the whole boat moves. Bam! Newton's third law solved. Thank you guys so much for watching this video. I really hope I helped you understand Newton's 3 laws of motion. And if you want to see more cool science stuff like this, make sure to comment down below. Make sure to subscribe. Let us know what you'd like to see next. And yeah, thank you guys so much for watching. Hope you guys have a great day. See ya.